Well, start learning about the creation of his objects. So in this section, we need to master the creation and use of objects, to be able to independently complete the creation of objects, and through the object, and access its properties and methods. Okay, so in the last section, in our previous section, we defined the class. We're going to create the object. Let's go back to the idea. So now, I have this random class. So how do I create the object? Okay. So let's go back to creating a main class, which means, that is, the class in which our program is going to run. In which class the program is going to run. Let's say I write a class. Okay, to make it easier for you to see, I'm going to move this file to the right. Now on my left side, I'll start writing our test code to test the creation of objects in this class. So how do you create objects in the first place? Look at the first thing. We declare a type student. We create an object name. And this object, we can equate this object with a student. It's to create an object. And copy this object. And copy its address value to this student. Okay, so now we can create the object. Then after we've created it, we can pass it through the subpuncture form inside to him to copy. Okay, stu.dots on an h equals 18. Stu.dots on a sex equals men. Then I can adjust its method. Put a dot on it. To execute it and see if it's copied, click on the execute button. Come on, let's wait a moment. Come Jong-sen is studying. Lee Si is playing games. Through this object stu, you can access the properties of the object stu in the form of dots. You can copy or output. That is, if I want to print the value of this property, I can print the value of the attribute. If there is no equals sign followed by, what's the equivalent of this? It's getting the value. If there's this equal sign followed by a sign. Okay, let's do it. Do you think it's Lee Si? Jong-sen is studying. Why is this Jong-sen? Because we said, what we talked about in the last lesson. What is this variable? Is it a local variable? It's a local variable. Okay, let's go back to PPT. So in this case, the name of the class, then the object name is equal to the class name. In other words, at this point, it's executing it into separate steps. So let's go back to idea. Can we also choose to do this? This is another way. For example, then IQ is equal to a student on a chick. Isn't that the same thing? It's the same, just separate. Then let's see. So this time we see, creating an object at this point is divided into declaring the object and instantiated object of 2 steps. You can also create an object directly in the following way. Creating an object, if it's just like this, he is declaring the object. Declare the object. And then new actually creates the object. Okay, so let's get to the point. This is the way to do it. It's just a matter of declaring it and instantiating it at the same time. Then we go to how to access. Access is very simple, you can see. After we create him. In the main method, we instantiated object. The name of the object is HTU. Then use the keyword to create the object. Where does it exist? It exists in the heap space. The memory allocation of the object can be as follows. You can see. Open a space in the heap to store the object. Then at this time, his object is in the heap space and references it. I can also draw a diagram for him to show him the example just now. Let's find the drawing tool. So let's put the code here. So its underlying structure is like this. This is a stack. This is a heap. When I go to twist, it actually does something. So this opening of memory, it's going to be assigned an address value. Let's say it's 0 by 11, okay. So stu, as a variable, it's going to be stored in the station. Stu. STU points to this address in their heap space. To this address in their heap space. That means they are accessing our object. That means the whole stu. It is equivalent to taking this address value. Take this address value and pay it to him. Understand? Then we can print his inner workings. To this area of heap space. Okay, back to the PPT. As you can see, this is pointing to the corresponding heap. It's that at the beginning, our attributes to him, before we copied them, he has a default value. For string, a default value is null. For int, the default is 0. Double is 0.0. Boolean is false. So are we going to duplicate it later? Once we've copied it, we can use the object. Click on the name of the object, the name of the attribute, direction. We can access it through. This access is not only for copying, it can also be a good value. So let's go through this case. We can go to demonstrate the whole process of creating an object to demonstrate. Let's go over it again. This is very important. That's why students must master it. Watch this. Let's create another. Create a test class. This test class is just this main method. And this main method is the main entry point for the program. It's the entry point to the program. It performs the process of creating the object and calls its properties and methods. Okay, so let's create the. You can start by declaring. You can declare it first, right? We can then create. That is to say, instantiated object. So is the pointing to a memory space. In the heap. Inside the heap. the initialization value is not null. We can access the inside of the inner. Come on, let's go. Zhongsan is reading. That is to say, this process is actually equivalent to what in the figure. So when I go to call what? When I go to stu and I bring this code here. And then change it to who? Then some students may ask, then this method. He is chasing in the method area. There is a method area. It's actually in the method area. Inside the method area. So the method area is in this place. He has an address. Let's say it's called OX22. So there's a method reference in this area. What's the equivalent of a reference? It's a space that he can point to. It's good to point to this space, and then refer to the method. When you call this method, it is given this address value, OX22. This is called a heap. This is called a method area. Method area. Okay, so this is a basic flow process. Then we can see in this case. We can see, now create an insider. Attribute has a method. So when I created this object, so there are two objects at this point. Right, you used it twice, didn't you? Two objects twice. And they have different names. One is called IQ1 and the other IQ2. So when I print this, I'm asking the second method, who is this one? To pay attention to see, at this time is equivalent to what? In this place we create another object. Will there be another space in our space? Another space is created. Note that another space has been created. Then this one. Another new address, say OX22. The default address at the beginning of the program. We created an attribute called stu2. Doesn't that point to this space? So they don't interfere with each other. So his IQ1 is stored in OX11. And what's this one? OX2. I'll paste the code into the diagram. I'll take this one over here. Okay, come here. Equivalent to double quotes Lisi. So what does this line of code do? Is it the same as just now? At this point, are we just going to click the stat click? Isn't it changed to who? Lisi then Lisi copy over. Said they two are independent of the two spatial. Once again, it's like creating a new object. Is the method you used to this time? Is the method the same method? Then he also references this method at this time. Refer to this method. Okay. Then this method reference is written here. Method reference. Then the reference is also x to 2. Okay, this is our whole what? The whole execution process. Back to the PPT. So the whole process. This is a case study we did. So we have to read. Once the execution is not one called Zhongsan and Lisi. Right, Zhongsan is reading. Called Lisi is reading. It's about object creation and the memory map of the empty heap. Let us stop here.